Hello, welcome to this lesson in Algebra 1. Here we're going to continue learning how to multiply polynomials by monomials. But to change it up a little bit, instead of just multiplying things, let's try to solve some equations. So at first you might say, well, how do I do that? Well, you just got to use all of the rules that you have. So if I had an equation like this, 3x minus 1 plus 2, 4 minus x. What do you think you would do? A lot of students get confused when they look at this and they say, well, this is crazy and this is crazy and I have x here and x here. What do I do? Well, you know that you can distribute this 3n and you know you can distribute this 2n. So then once you do that, you're going to collect all of your x's together, your like terms, and then try to isolate x as you have learned in the past. And so this only extra step here is doing the distribution. Because now we're learning how to multiply monomials times polynomials. So let's go ahead and do that. So we have 15 equals, now when we multiply this in, 3 times x is going to give us 3x, and 3 times negative 1 is going to give you negative 3. So we're kind of doing the multiplication as we go here. Then we have plus. 2 times 4 gives you positive 8, and 2 times negative x gives you negative 2x. So now you see what you have on the right-hand side. This is a like term with this. So 3 minus 2 is 1. 1 what? 1x. So I just write it like this. And then I have negative 3 plus positive 8. So you can think of that as 8 minus 3 effectively, and that gives you 5. So now this is an equation that you solve many, many times. How do you get x by himself? Basically, you subtract 5 from both sides. You do the opposite of the addition here. So it's going to be 15 minus 5 is equal to x. I'm subtracting it from both sides, but it disappears on this side, giving me 0. And on the left-hand side, 15 minus 5 is 10 is equal to x. So another way to write that is x is equal to 10. And I'll leave it as an exercise to you. If you take 10 and stick it in here, and 10, stick it in here, and multiply and add, you're going to get the 15 that you're seeking. So you see, now that you know how to do this multiplication, it's going to allow you to solve more complicated types of equations. For instance, if you had y, parentheses, 2 minus 3y, plus 3, y squared minus 4 is equal to 0. See, if I were to give you this like 10, 20 lessons ago, you wouldn't have any idea how to do it. But now you know that it's always legal to distribute this stuff in. This is a monomial, this is a polynomial or a binomial. So it can go in, this can get distributed in, and then I just collect terms. So y times 2 is 2y, and then the y times negative 3y, think about it, is going to give you negative 3, and then y times y is going to give you y squared. You add the exponents. 3 times y squared is going to give you 3y squared, and then 3 times negative 4 is going to give you negative 12, and that's going to give you 0. So all we did was distribute things in. Now, we look at this, and I noticed something interesting. I have negative 3y squared and positive 3y squared. So these are like terms because they both have y squared. So negative 3 and positive 3 are going to add to 0. So to show that, you don't really have to write 0 down, just strike it out. And your teacher's going to know that those basically add away to 0. Everything else you can just continue to write down here. So 2y minus 12 is equal to 0. How do we get y by himself? Well, first we're going to move the negative 12 over there by adding 12 to both sides. So it's going to be 2y is equal to 12, because when I add 12 to both sides, it goes to 0 here, and then 0 plus 12 gives me 12. Then I can divide both sides by 2, as we've done many times before, which causes these to go away since they divide away, and all I'm going to be left with is y is equal to what? 12 divided by 2, which is 6. Y is equal to 6. Same thing. If you take 6, stick it in here, stick it also in here, and do all the math and order of operations, you're going to find out that all of this stuff, and also you'd have to stick it in here, everything is going to sum to 0, that's the solution that works. We'll do one more, just to give you a little bit more practice, and we'll call it a day for this topic. If you have 2 times n minus 3 plus n times 2 minus n is equal to 2 minus n squared. Again, if you were to look at this 10 or 15 sections ago, it would be like, what do I do? Now you break it in simple steps. 2 times n is 2n. 2 times negative 3 is negative 6. And then you have a plus sign, and then n times 2 is 2n. And then n times negative n gives you negative n squared because you add the exponent since the base is the same. On the right-hand side, I just keep track of everything. Now let me attempt to collect terms on both sides. So here on the left, I have 2n and 2n. These are like terms, so I can go ahead and add those together, and that's going to be 2n plus 2n is going to give you 2 plus 2 is 4, so it's going to be 4n minus 6 minus n squared on the left is equal to 2 minus n squared on the right. All right, now here's the interesting thing. You see the n squareds here, right? So you want to try to combine them because they're like terms. So you try to do that, but when you end up trying to do that, you would have to add n squared to both sides of this equation. Let's just see what happens when you do that. 4n minus 6 minus n squared. So we're going to do the opposite, add n squared, is 2 minus n squared minus n, plus n squared. Basically, we added n squared to the left here, and we added n squared to the right here in an attempt to isolate it. But when we did that, we see in this case we have negative n squared, positive n squared, so these go away to 0. And we have n squared here and negative n squared, so these go away also. So they basically, you can't add them because they drop away. And you can kind of see that up here. When you have the same term on the left and also on the right, then you can basically strike them out from both sides. I could have drawn a line through it here and here, but then you wouldn't understand why. It's because if you try to move it over, it's going to disappear because they're basically both sets of terms are exactly the same on both sides, so it's as if they're not there anyway. So mathematically, you show it by trying to add n squared to both sides, and they all just drop away. So all I really have left is 4n minus 6 on the left equals 2 on the right. Now I know what to do. I'm going to take this negative 6 and move it over by adding 6. 4n is equal to 2 plus 6. So 4n is equal to 8. So I just added 6 to both sides. And then I can divide both sides by 4. That's going to cancel the 4s. They divide away. And so all I'm going to have is n is equal to, what is 8 divided by 4? Is 2. So that's the value. If you take 2 and stick it into here and here and here and here, and you'll calculate whatever you get for that calculation on the left will be exactly the same as what you get for the calculation on the right because that's the only value that works. So this is basically an exercise in solving an equation, but it's really an exercise in showing you how multiplying these monomials like this times these polynomials can be used other than just for doing it. They will be used as you go forward in solving equations. So it's a skill that you'll be expected to know. And I'm hoping that you kind of see as we go through this stuff that, you know, a lot of textbooks and teachers, they call on all these different things, you know, all these different skills by different names. But really, you already know the distribution property from before. You know that if you have a number like this on the outside of a parenthesis, you just multiply it into every term. Now we're doing it with variables and longer expressions, but really it's just the same distribution property. You just say that you're multiplying polynomials by monomials, but you end up doing the same thing. Algebra has a lot of fancy words, but once you understand the concepts and the basics, then really you just kind of get a deep understanding of what you should be doing. So make sure you can solve all of these problems. We're going to continue multiplying polynomials in the next section, but in the next section we'll be talking about multiplying binomials times binomials. So that will give us a little bit more of a challenge. Make sure you can do these. Follow me on to the next section now.